For the beam and loading shown, determine the slope and the deflection at point B, which is right here. Okay, so once again, this is a situation where writing out the full calculus equation elastic curve isn't too tedious, but it's still not as easy as just using the method of superposition. So as I look at this, once again, it's a puzzle. How do I put it together? Well, I can go look at tables of solutions for different loading conditions, and typically this is not one that you will see. So how do we go about solving this? Well, typically you will see that you will have one that gives you the entire beam loaded, and especially if you did the last problem, you'll see that there's a table that gives us this part here loaded and leaves the end free. Once again, this is where we're going to superposition things, but we're going to superposition things slightly backwards. Now, what do I mean by that? So this is how we're going to put the loading together. We are going to take from our book, we're going to look at the loading for a distributed load that goes across the entire beam. And then I'm going to add to it one where we basically subtract the loading on the first half of the beam. So instead of pushing down, we're just going to take the negative of it, flip everything so it's pushing upward. Now when I do that and I superimpose this condition on this one, since we're going to have this pushing up here, all of this stuff here is going to cancel out. And that's what's going to leave us with this cantilever beam that has just the front part open. So what are we going to do? Well, we're going to go to our charts and our tables. And so this is the page from the engineering equation manual. And so let's just identify, this is the one beam that we're going to use. Oh, actually, I want to use the highlighter. We're going to, and let's change the highlighter color to be highlighter color. So we have this guy here, and then we're going to use this one here, but we're going to use this one in a negative manner. And so we're going to need the slope and the deflection. Let's do the deflection first. So I have the slope here, slope here. These are both calling for the maximum slope, which we can see are at the end of the beam, which is what we want to do. Okay, and so we'll just look at it. So let's look at the overall beam. So we'll call the full the full loading. Change the color back. The full loading we're going to call 1. And so taking a look at 1 for the slope at the end, the max is negative WL cubed over 6EI. And then for condition 2, if I look at the slope, now condition 2 would be negative WL cubed over 48EI. So we'll call that, we'll just call that 1. We'll just call this one 2 for right now. Now, downward is negative. So remember for our vertical displacement, downward is positive. For our rotations, counterclockwise is positive. And I drew that clockwise, so that's not going to work. Counterclockwise is positive. So we are pushing up. And so this is the equation for if I'm pushing down. So if I'm pushing up, I have to flip it and add that together. Okay, so our maximum is just going to be adding these two together. So negative WL cubed over 6EI plus WL cubed over 48EI. And so as I put those together, theta max is going to be equal to, as we find the common denominator, that'll give us negative 7 WL cubed over 48EI. So that's a negative, which means that we have a clockwise rotation, which is what we should expect. Even though we're pushing up a little bit, this is a clockwise rotation, a counterclockwise rotation. We're getting a much more clockwise rotation than counterclockwise, which is why it's still negative. Okay, let's do the displacement. And so once again, we'll just look here. Here's our two displacements. So V1, which will be the overall one, negative WL to the fourth over 8EI. And then if I look at the displacement due to this, it'll be negative 7WL to the fourth over 384EI. Once again, this is pushing up, so it's reversed. This is positive. And so that means our Vmax will just be V1 superimposed with V2. So 384 EI. And then we just add those together. And so once we do that, Vmax, we will find, is going to be negative 41 WL to the fourth over 384 EI. Now, neither of these we still have W's, L's, E's, I's in it. It doesn't really matter, because as long as you can put this together, if you had the numbers, you can easily go, okay, well, the length is 10, the distributed load is this, you could solve this. But this is just another example of how we can use superposition to put together answers.